Hey there, Advanced Math. Today's mini lesson is on representing and finding surface area. We talked a lot about area for several days, and surface area, to remind you from yesterday, is finding the area on all the faces of a three-dimensional figure. Go ahead and write this as the next title on the next free page, and then close it up and listen with me. So here's some of the figures we talked about yesterday that we'll be finding the surface area of, just to give you some vocab reminders. So a 3D figure where the base is a rectangle. You know, this could be sitting on this part here. It could be sitting on this part here. It could be sitting on the front. But any base we put that on is going to be a rectangle. And so a figure where the base and the top, however you want to set it, would both be a rectangle. It's called a rectangular prism. This figure has a triangle on kind of the front and the back. We could stand it on the triangle. So usually on a figure like this, we think of it as sitting on the triangle, like this one, because we call that the base just because it has the triangle. But it's a triangle base with rectangle sides, and the rectangles go up and meet another triangle at the top. One shape like that is a triangular prism. So, you know, prism means the bottom and the top are the same shape, and the sides are rectangles, pretty much. And then these two are similar but not quite the same. These are both called pyramids. You notice, like this one, that there's a base that's a triangle and the top is a triangle. On the pyramid, the base is a triangle, but the top is not. It comes to what's called an apex point up here at the top. So a pyramid where the base is a triangle is called a triangular pyramid. And a pyramid where the bottom is a rectangle or a square, which is a type of rectangle, is a rectangular pyramid. So those are pretty much the main four figures in 6th grade that you're going to learn to find the surface area of. So let me do a couple for you here. So here's one. So the rectangular prism below is going to be painted red for a craft project. How many square inches of red paint will be needed to cover it? So lots of times surface area projects involve like covering, right? Like wrapping it or painting it or something that doesn't fill it up, but deals with covering every single side or face of the figure, right? This one has 6, and so that's what surface area is. It's this is just a rectangle, and the bottom's a rectangle, and the front's a rectangle, and the top's a rectangle, and the side's a rectangle, and the back's a rectangle. And so the surface area is finding the area of all the different faces. To do that, yesterday we looked at representing these as what we call nets. It's almost like we took this piece and unfolded it into 6 different rectangles. And we usually think of doing that as I like to think of that as starting with the base and unwrapping. So like if I set this on the base, maybe I could fold this side down. So let's start with my base. My base is 6 this way and 8 this way. So then maybe I take this side, this face, and fold it down along this edge. So then I have like another one over there. So this 8 side stays, but the one over there would be, look, this is only 4, whereas this is 6. So it's going to be a little skinnier if I unfold it. So that side has a 4, when it's down there, a 4 on the bottom, and still has an 8 up and down. And that other side would do the same thing, because that's the same side. That's a 4 here and an 8 here. Now the top would have to also be folded off of one of these sides. It would either have to go with this side and kind of like come over next to it, or do the same thing on the other side. I'd have to put it somewhere, so I can't lose my top. So let's say my top went off this side. So the top matches the bottom, right? It's a 6 by 4. So I'm just going to go, I'll put it over here. And if it helps you, or not 6 by 4, a 6 by 8, I'm sorry. And sometimes it can help. This is kind of, if you write the parts, this is the base, top, side, side. And then there's also the front and the back, so they would kind of go here and here. So that would be off of my base, a 6 up, or a 6 base and a 4 up. And 1 here. Back, front. And that's something we call that the net. I don't know where that term came from. That's the net of this figure. And we do that because it makes it easier to find the surface area. Now I can easily find the area of this rectangle, 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 of this rectangle. If I do it, let me change colors to make it more clear. So these are all 8 up, right? That 8 along the base, all of these are 8 high. So this is a 6 by 8, it's 48. The base is also a 6 by 8, is 48. The side is a 4 by 8, is 32. 4 by 8 is 32. And then the front and the back are a 6 by 4. 6 by 4, so they're a 24. 24. And then to find the surface area, I would add all those up. I'm going to get a calculator and do that real quick. I'm going to pause. And I got 208 square inches. Of paint. So that's what I would need to cover the outside of the whole thing, its surface, the area of all of its surfaces, 208 square inches of paint. All right, let me do another first. So I'm going to say this box company, Beyond Boxes, is considering making a box that looks like this. A triangular prism, triangle base, and 3 rectangles. So we're going to make its net, and then we're going to see how much cardboard it would take to make the box. So again, that's kind of an outside, how much cardboard. That's kind of another kind of cover type question, and that's what you see a lot with surface area, is what you need to cover it. Alright, so it's sitting on this rectangle side, so I'll leave it on that rectangle side. I'll draw that first. Looks from my figure like that is it's a little box, 3 centimeters. What am I going to do with this box? 3 centimeters by 8 centimeters is my bottom. Let's make sure I get everything. Count my sides here. I have a bottom, side, the slant, that's 3, the front and the back. So make sure my net has 5 sides when I'm done. So here's my bottom. Maybe I'll do the front and the back next. So they're going to make a triangle here and a triangle here. They both already have the base. The base is 3, and this height is 4 here and 4 here. And then I would maybe fold the slanted side out here that way. Looks like that's going to be 5 and 8. So I already have the 8. The 5 is going to be bigger than the 3, so I'm going to draw it a little wider than the 3. So it's going to be a 5. And then I can take this straight up and down face and fold it back that way. It's going to be a 4 by 8. It's the 8, so I'd have a in between that's here. Alright, and there, 4 and, remember all of these are going to be 8, 8, 8, 8, 8. Anything with this is an 8, this is an 8, this is an 8, and this is an 8. So now I'm just going to pause real quick, and I'm going to, well, I'll remind you, before I pause. So this is going to be an 8 by 4. That's a 32 area. This is an 8 by 3, 24. This is an 8 by 5. And now one easy mistake to make, I've got triangles now. And remember, triangles are not base times height. They're base times height divided by 2. So the triangles are a base of 3, height of 4, which is 12, but I have to divide that by 2. So they're going to be 6 each. 3 times 4 divided by 2. All right, I'll pause real quick so I don't waste too much time and add them up. And looks like if I add up all the sides together, I get 108 square centimeters of cardboard. All right. All right, open your math notebook. Let's do one together. Here. Do another triangular prism for your note. So she wants to cover this with scrapbooking paper, like wrap it. And again, we're covering it, right? That's always a good sign for surface area. If you want to pause, there's a lot of parts to this question. Why don't you pause and write the question down, and then we'll work it together. All right, so sketch each unique face below. So we're gonna, that's kind of like each face. You can draw the net, or you could just draw, the way this is worded, you could just draw the 5 sides separately. You know, you could just draw, you know, front, back, bottom, stuff like that. I usually like to draw the net, but if it's easier for you to keep track of it if you draw them separately, that works too. So go ahead and pause. I'm going to pause. Either draw your faces or draw your nets and label all the sides. And there are my drawings. So if you want to draw the net, which this doesn't say you have to, the net would look kind of like this. You'd have your 4 by 12 bottom. And then when you folded these two out, you'd have 2 7 by 12 faces there. And then the front and the back, notice it gives us the height out there, would be a base 4, height 6 triangle. If you just want to draw the sides separately and not as the net, that's totally fine too. The main thing is just to keep track of all your measurements. All right, so now we need to find our area of each of these. So these are my 7 by 12 sides. 5 times 12 is 60, which means 6 times 12 is 72. So 7 times 12 is 84. So this is 84. This is the same. So this is an 84. Base times height, 7 times 12. The middle one is a 4 times 12. Base times height is 48. And then don't forget, when you've got triangles, you can't just do base times height. You have to remember to divide by 2 for triangles. So base times height is 4 times 6 is 24. So each one is 12, half of 6 times 4. So that is the area of each face, 84, 84, 48, 12, 12. And so the last question here is well, if Stephanie has this much scrapbooking paper, does she have enough to cover her entire little figure? And so we have to see. So we would need how much here? 84 plus 84 plus 48 plus 12 plus 12. So it looks like our surface area of our figure was 240 cubic centimeters. Or I'm not, sorry, cubic, square centimeters. And she only has 25, so she does not have enough. And my explanation would be, we find our surface area, we know we need 240. And so 225 is less than 240 that comprises the surface area of our figure. So we don't have enough. All right. So that's how surface area works. You just kind of unfold or take apart the 3D object, and that helps you envision the area of each face and then put it back together. All right. If you need to watch any of these examples again, go ahead. Otherwise, after you've got this one written down, you're all set, and we'll try a few tomorrow. See you then.